Okay, let's get started. So welcome everyone on site and remote to the session of the core working group at IETF 119. I am Marco Tiolka, my co-chairs are Jaime Jimenez and Karsten Bormann. And before getting into the core of the core session, huge congratulations, Jaime, for the new addition to the family. And of course, and thanks for bringing in new area directors, working group chairs, minute takers, whatever. Thank you so much. Best wishes.
Thank you.
Okay, people today are assumed to have read the drafts, including the agenda. Our goal is to make good use of our time to discuss issues and open points, at least in a synchronized way. The attendance list is compiled automatically by Miteko. I'll keep a look at the chat. Today, we have two note takers, Christian and Ricard. Thank you so much for helping. Chairs will also help. And of course, this is an official IETF meeting, so the note well applies. Please get familiar with that if you're not already. It's not only about IPR, patents, and so on. It's also and especially about our code of conduct. So please be nice and professional with one another. A few practicalities. We've been recorded, and for the in-person participants, remember to sign in with Miteko, preferably with the on-site tool. You can find the link on the data tracker and the screenshot in this slide. If you prefer to use the full client on the web interface, be sure to not send in audio or video. Regardless, if you want to join the queue, please do that on Miteko first and then go to the mic. For remote participants, also please don't send audio or video unless you are presenting or you're actively speaking in the queue. Try to use a headset to minimize echo and background noise. If you cannot speak, please type mic and your question, comment in the chat, and we'll relay the comment on the mic for you. Okay, this is the quite packed agenda for today. We'll continue with this chair slot for a while with updates on the working group and the documents. Then we have Karsten leading two slots, one on the remaining documents of the core conf cluster and one on the href document on CRIs. Then Martina leads a slot on two documents, DNS over co-op and the newly released related core DNR. Christian lists the slot on core protocol indication, and we had two versions released since IETF 118. And ESCO presents an update on the new working group document about group communication for co-op with proxies. And then Ricard has two slots related to OSCORE, one on OSCORE capable proxies and one on two documents on updating key material or identifiers for OSCORE. And then we concluded a number of slots on individual submissions, two led by Christian on co-op non-traditional responses and on core resource directory extensions, and the final slot led by Carles on two documents, co-op over bundle protocol and in space. Does anyone have any bashing to propose for this agenda? Okay. Heard none. Let's get into the status update on the documents in the working group. Two documents have been recently approved for publication. Target at for a while. Actually, it's with the editor queue also for a while now, stuck with a tool issue. Hopefully to be resolved soon.
The tool issue has been fixed in the repo. It just needs to be deployed, and then we can go ahead.
Awesome. So just a matter of days, hopefully. Core seed was also approved recently, and it's in the editor queue, not stuck, just under the regular process, as far as I know. And it's anyway on today's agenda in the core conf slot. Then we have one document that completed the IETF last call and has entered recently in ISG processing. It's scheduled for the first chat in April. Carsten Shepard, the assigned AD is Paul Waters. And then we have a number of documents in the wide post-working group as call processing. One is Grupo Score on its version 21 now. Is still waiting for Shepherd write-up, and the latest version did address the comments from the Shepherd that have, of course, to be confirmed. And then we are really waiting for the write-up, so we are on Christian's hands for that. Then we have the two remaining documents from the CoreConf cluster that Carsten will cover on today's agenda. Komai, that underwent a number of updates. More are expected before a next working group class call. Young Library technically is waiting for Shepherd write-up, but has been put on ice for a while, waiting for Komai to be pretty much completed, and we'll resume from when we stopped, and most likely have another working group class call. On the second half of the document's post-working group class call, we have also a group combis that has proceeded in parallel with Grupo Score. This is waiting mostly for a confirmation of resolved comments from working group class call from Carsten. Francesca.
Yeah, about group combis, I just wanted to highlight that we have documents in ACE that depend on this, and the group commos core that was on the previous slide also is dependent on this, so it sort of like should be prioritized. Probably we should move it forward.
Thank you.
Will do. Thanks.
Thank you. Another document under the same basket is conditional attributes. It completed the working group class call half a year ago or so, and we are waiting for Bill as the driving author to produce version 7. Addressing some of the remaining comments, but it was confirmed already a few meetings ago to have this document as a proposed standard instead of informational. And then we have href also in today's agenda, and as far as I know, a few points are still left to address, so version 15 is awaited anytime soon to be considered for progressing. Okay, on other documents, there's a bunch of other working group items not in the agenda for today that have been updated recently, so please have a look at those and provide comments. Two documents have been recently adopted instead, Group Com Proxy last December, and OSCORE ID update, well, it appeared a few weeks ago, right before the cutoff. This is the result of a split out from OSCORE key update, now as a substanding document as agreed at the last IETF meeting. And they are both on today's agenda. On yet other documents, we have had a number of individual submissions updated recently. Please have a look at those, provide your comments. Two of those documents from Christian are also on today's agenda among the final slots. And finally, a number of brand new individual submissions that we managed to all include in today's agenda. So they will be presented. Okay, that completes the update on the documents in the working group. We have already planned, scheduled, and booked the next series of interim meetings for core. So we plan to resume on April 10, and then continue according to the regular cadence every other Wednesday at 14 UTC for 90 minutes. And we plan to skip a meeting that would have been in the second half of May, since it collides with an IoT security hackathon held at INRIA Paris, and also co-located with the T2TRG interim meeting. So we'll skip that one, but other than that, the pattern is pretty regular, and as usual, we alternate with a similar pattern on the other weeks of the CBOR working group. And on other hopefully useful information, there's a thread in the core mailing list that Carsten started to point to a rehashed discussion started in HTTP BIS that led for the possible consideration of MDNS for node discovery. There has been some exchange there already. Please feel free to contribute to it. Carsten.
Yeah, just quickly noting that in the IoT Ops meeting after lunch, we will have some related discussion, which unfortunately currently is not on the agenda. I'm not sure what's going on there. But we will have a new attendee talking about problems in this space. So I think this will be an interesting discussion, and I encourage people to come there.
Wonderful, thanks. Okay, then I quickly mentioned already before when talking about the calendar for the interim meetings, an event organized in Paris on 21 and 22nd of May at INRE Paris. It's a hackathon on lightweight IoT security. You can find more information at the dedicated website, and registration is open. Please consider. And co-located at the same event and possible to attend both on-site and remotely. There is a T2TRG interim meeting on the Wednesday in the European afternoon. So same thing goes. You have a link to the related GitHub entry. Please consider to register and participate. Carsten can possibly give more information. Okay, so that was all for the introduction from the chairs, unless there are any comments or questions. I don't see none. We saved 9 minutes, 4 minutes already, which is good. And we can go ahead with the first presentation from Carsten.
Okay, so let me quickly talk about CoreConf. As you know, this is a set of 4 documents. One is published, one is in the RFC editor queue, has been there for 9 weeks. Currently, RFCs take much longer than 9 weeks. COMI is the one I will mostly talk about today, which has passed working group last call, but there was a good set of comments, so we would take a little bit more to process them. And then there's Yang library, which passed working group last call, but the issue about Yang library is that it's really the representation of the feature set that a COMI implementation will have. So while we are working on COMI, we will probably have further requirements for changes to the Yang library. So we are currently looking at finishing COMI first. There's also I should mention, a submission to the CBOR working group to maybe make use of a more general CBOR idea that we have called stand-in tags to optimize 9254. So 9254 Yang CBOR is essentially taking the JSON, Yang JSON, representation and getting rid of the complexities caused by JSON, so that's fine. But in its heart, Yang is an XML format, it's a text-based format. So there are still things like IP addresses or time and date strings that are represented as text strings in Yang CBOR, and that's both wasteful and actually something that constrained implementations actually have to write significant code for to fix. So we are looking at using CBOR tags to exchange these in binary, but that's on Friday. Okay, so let's quickly talk about CoreSID. So this is approved, it's just waiting for publication, but there is also remaining implementation work, which we started at the last IETF. And the real problem here is that Yang is supposed to handle message data items. Yang normally is doing data at rest, so management information bases can be read and written. But there are some Yang extensions for actually specifying data items, messages, in-flight data. And these exist in theory. I mean, they exist in the draft, in the specifications, excuse me. But we have found that it's really hard to work with these implementations. And we actually had more discussions about this in Anima. And I think it's now clear how to do the rest of the work here. So this is upcoming. So on to the main point here, Komai. As I said, this is based on Yang SIBO and on the SID management. Basically, it's completing the set of something conf specifications. So netconf was XML over SSH, essentially. RESTconf was XML or JSON, and now SIBO over HTTP. And CoreConf is SIBO over CoAP. While we are moving from HTTP to CoAP, we are also simplifying things somewhat, so we have a much less elaborate data store model than RESTconf has. So this specification was started in 2013, and it took a while to find the right approach, and now we are in the process of finishing it. Dash 17 processes some of the working group last call comments. In particular, it clarifies that this document really only talks about the unified data store. It mentions the all or none semantics, which should maybe be a global property of Yang protocols, Yang-based protocols, but apparently aren't. So we have to do this explicitly. And we might want to have a hallway discussion here at this meeting about the candidates feature that is currently, private candidates, that is currently being discussed for the other something confs. We fixed the RBC action examples and no longer have redundant or superfluous nesting levels there anymore. And we had tons of editorial fixes. May have to fix one of these fixes and clarify the fetch request response pairing further. So we had we had three substantive comments during the working group last call. One I don't have a slide for because these were just very good editorial comments that we put in. Kuhn's implementation report led us to actually simplify CoreConf, and we have one potential simplification we can do, and we probably need to decide whether we want to make this additional change at this point. Will make things very much simpler, but it's also a change. We have a pretty substantial input from Andy, who also indicated that he will have some more input. We have pretty much done the editorial stuff, but there are three issues still in the tracker. One is the need for examples, and the other one is the need for better examples, so 14 and 16. This is just work that needs to be done. And 15 is discussion about potentially having filter parameters that really work for constrained devices, but this may also be something that we leave to a future extension. So we have to understand that. Basically, the current idea is that with constrained implementations, you also have a somewhat limited information base. So it's okay not to have these filter parameters like depth in RESTconf. But maybe the reality is that these information bases are growing and the need for these filters is increasing. But then depth doesn't really work that well either. So just copying it is probably not the full answer here. That's why this is an ongoing discussion. So the plan is to get those remaining comments that I just talked about addressed and get all these examples made. Which are always a bit of a chore because they're hard to test with the software we have right now. And that will lead to a dash 15, and we probably will do another working group last call then. So that's Komai or CoreConf in general. Any questions? Then we'll move to the next item on the agenda, which is CRIs. CRIs are an attempt to be able to exchange parsed URIs. So URIs are text strings that you have to take apart and do various processing on. And in CoAP, we actually decided to parse them and turn them into CoAP options. That's great, but this uses the CoAP encoding, and it would be nice to have a CBOR encoding for that as well. So that's why we are working on CRIs, and we are also trying to increase the coverage. Now, funnily, one thing we didn't actually do before this version 14 was actually describe how to translate between the CoAP representation of URIs and the CRI representation of URI information. So this is a new section, and we did other minor things like doing a diagnostic notation way of talking about CRIs, which you don't need, but makes life easier. And there are a couple of chores that have to be done. We definitely need more test vectors. We decided to make the scheme registry non-negative because CoAP only supports non-negative numbers, unsigned numbers. And so far we had made the registry out of negative numbers, and we will switch this into non-negative numbers. Just the representation in the CRI will then be a negative number computed from that. With the recent discussion about deterministic encoding, we see a need to clarify the determinism objective of CRIs. So CRIs actually are deterministic, while CRI references really can't be, so we are not trying to. So the new stuff, using your CRIs with CoAP essentially mirrors section 6.4 and 6.5 of RFC 7252, which does the same thing for URIs. We also generate two new analogous options. So the analogy to, or the analog to proxy URI is a proxy CRI, and the analog to proxy scheme is proxy scheme number. So this, more slides on each of these. So this is essentially just the option structure. It's opaque from the point of view of CoAP, but of course it's a CBOR encoded CRI. And yeah, we had to define what happens when you put in both proxy URI and proxy CRI. And the proxy scheme number needs to be an unsigned integer, because in CoAP we cannot encode anything but unsigned integers. We could, of course, make this into a CBOR encoding, but that's really not needed. So we decided to go for unsigned integer URL scheme numbers, rephrase the registry in unsigned numbers, and just explain how to compute the negative CRI scheme ID. So this is not a technical change to CRIs themselves, but it's a significant editorial item because there are programs that generate the initial values for the registry and so on. And this reprogramming hasn't been done so far. Okay, so the plan for href is, the CRI document is called href for historical reasons, is to get those test vectors in place that I've talked about, do the other to-dos I talked about, and have an ID to probably last call again in approximately May, or maybe a little bit earlier than that. Any questions on that? Good.
And that's just a comment from Christian on the chat. The uint encoding also makes the proxy scheme option very short, 0 data.
Yeah, if you just do a CoAP URI, then you can express this in 0 bytes, which is better than CBOR's 1 byte.
Right. Okay, thanks a lot, Karsten. If there's no other question, we can switch to the next presenter, who is Martine. So I can open the deck, Martine, and switch control to you. Yeah, you should have control now.
Yeah. Hello. Good morning, everyone in Brisbane. I want to talk about DNS over co-op, which I talked for a few years now about, and also about our newest document, Discovery of Network Designated Co-resolvers. So the idea behind DNS over co-op, for those who weren't here the last times, is basically that we just want to protect DNS requests against eavesdropping. And we decided to use co-op for that, so we can use encrypted communication and also the blockwise message transfer to segment the DNS messages, and of course share system resources with co-op to save memory. Basically, the only change since the last IETF in Prague is that we added some references to the relevant Service B and DNR RFCs and our own draft, which I will talk later on. And so basically most of the deliverables that we were asked at IETF 118 for the working group last call were fulfilled. There was a question of implementations. There is our Python and Riot implementation, and there's also a bachelor student of ours who's working on an implementation in Unbound. My question would be if there are more implementations by the working group, maybe? Apparently not. Okay. And then the other deliverable was that we were supposed to provide a problem statement regarding service bindings, which became the draft I will present in the remainder of the talk, which is about DNR. Carsten, could you elaborate on your chat statement? I'm a little bit confused.
Yeah, of course, everybody knows that Unbound is a server, right?
Yeah, okay. Okay. Well, I'm actually not sure if so it's a resolver, so there's also some it can also go upstream as a client. So I'm actually not sure if the student will only implement the server part or also the client part. So
Yeah, so I think it would be good to have maybe have 3 columns here: server, client, resolver.
Yeah.
So people know which parts are covered. Thank you.
So regarding resolver discovery, so the current landscape is that for all the DNS over HTTPS, TLS, QUIC, there is this discovery of designated resolvers, short DDR, defined in RFC 9462, which uses basically Service B records definition from the 2 preceding RFCs. And there is also a discovery of network designated resolvers, short DNR, which is specified in RFC 9463, which uses DHCP and router advertisement options and reuses the service parameters from the Service B records in these options. And this basically looks like this. So we have these 3 message types, DNS Service B records, IPv6 router advertisement options, and DHCP v6 options, where we have basically a lot of overlap between the fields, some lifetime, some priority, a name that is used for authentication, addresses which are delivered in DNS, of course, with A or .A records, but so they are not in this specific option, and some service parameters, which are made up of a key, a length, and a value, so your typical TLV. And so we were wondering what is actually the problem with resolver discovery for co-op, so for DNS over co-op. And so basically some keys and values are missing for the service parameters. There exists already for ALPN, co-op tier ALPN, which is defined as co-op over TLS. So we also registered some for co-op over DTLS, which is now ALPN equals co. Then we also need some way to identify a transfer protocol beyond TLS and DTLS, which is the co-op transfer key. And in Christian's talk, I'm sure he will also talk a little bit about that. And then for OSCORE and ACE, we also needed some keys. We defined them also in the draft. And of course, we needed an equivalent for the DOH pass. So some doc pass is also needed. And so, yeah, and for the authentication domain name, we wondered what this would be for OSCORE. And so at the moment, we decided to either have no name if we don't want to authenticate, and maybe future proof for some SEA style authentication with ad hoc. But all in all the problems we found were easily solvable. So we solved most of them actually already in the draft. And so we more ask for feedback from OSCORE and ad hoc experts. So if you are an expert on that, please have a look at our draft. So given that all the deliverables are basically fulfilled, I'm asking the question again if the DNS over co-op draft is ready for working group last call.
Thank you, Martina. Any comments or questions? So from my point of view, the document can be considered for a working group last call. Karsten, Jaime, what do you think?
Yeah, I'm just wondering whether we want to put this into one bucket with DNR, because maybe it's not so useful without that.
Well, you can use it without DNS over co-op being discovered. You have to just configure it manually, of course. Yeah. Christian?
Yeah, I agree that the discovery options for co-op over DTLS, I think we fixed the one or two items that were missing there, so those could just be used. The large work for DNR is about integrating this with ad hoc and OSCORE. I think this will take a bit, might take the larger part of the remaining year, and the other parts are ready. So I think with maybe a bit more explicit a statement that the easy parts work, we could already use DNS over co-op without specifying out all the last details on how to do DNR with ad hoc.
So should we move the thing about DTLS maybe to DNS over co-op? So we have a document that has at least one battery included, and we are supplying the other battery later.
The problem I see a little bit with this is that the DNS over co-op discovery, DNS over co-op over DTLS discovery, is not just something that you might want to do with only DNS over co-op. So you also might want to discover some service binding for co-op over DTLS. So I'm not sure if the doc draft is the right place to have this. So I would rather maybe, if we want to go ahead with having some form of DNR already defined and then later work on ad hoc, divide that part of the work so that you have a co-op over DTLS discovery draft and then a co-op over OSCORE ad hoc discovery draft or document.
That's good to me. So we could still accelerate the DTLS side where we know how to do things, and work a little bit more on the ad hoc side, OSCAR side. Okay, but that is then no longer relevant to the question on the slide. In that case, I would say, yeah, sounds good to have a working class call at this point in time.
Well, it is. Sorry.
No, finish. I want to say after.
It is partially relevant because if we went as you suggested and moved that over, that would have been moved into a working group document. And if we now split that out right away, that would need a working group adoption to progress.
Right.
No, I just wanted to mention that it will be good for the chairs whenever they do working group class call to also request early reviews. We have directorates and there is a DNS there. And so I think it would be good to request that at the same time. So we.
Yeah. Completely agree.
Thanks. Okay, then we'll start soon a 2-week working group as called on DNS over co-op. Thank you so much.
Okay, thank you.
Okay, so the next presentation is for Christian, protocol indication or transport indication.
Yeah, that's probably a good clue to get started here. The document used to be named transport indication for a very long time, but had protocol indication in its human readable name. So I went with the unification there in the latest upload that came in just yesterday because I didn't finish all the things that I wanted to do before the cutoff. Another important change on the metadata is that Martina has joined me on the authors list because we're collaborating on the topic of service parameters that she has already mentioned are relevant for the for discovery and play into this as well. So for a very short recap of what the whole document is set out to do, it is to enable the discovery of proxies that allow, enable the discovery of alternative transports. That is, for example, if a resource is available also on co-op or TCP, then the client should be able to find that without introducing new URIs for everything, without introducing additional cost per request. And this should also work well with proxies. What I'd like to focus on today is how this is addressing the whole co-op co-op scheme versus co-op over TCP scheme issue. So what we've talked about during IETF 118 is that what the historical background is for why those are different, being that with IP literals you just can't distinguish otherwise what the protocol is. Whereas the observation from the T2TRG meeting in Prague was that actually everything that is not IP that does not contain IP literals or DNS resolution before service P records would just work with a single scheme. So that is now, and that is one of the changes in the latest versions of the document, also recommended for new transports. It is possible, and described in the document how, to use the co-op scheme for multiple for new transports, with some caveats, and those caveats kind of depend on the history lesson. So one of the remaining questions really is what should we do if someone came around with an implementation with a transport for co-op that is again using IP? Because most of the new transports that we're discussing, co-op over GATT, co-op over SMS, co-op over we'll have a presentation on bundle later. They're using transports that are not IP based, but that have their own addressing scheme, and we won't run into the issue of a port could be a UDP port or a TCP port there. This is really IETF stack specific. The document now has guidance on what to do in that case, but following up on that guidance might not be trivial. So that those appendices that describe what should happen in that case, I'd like to ask for good working group review on that and input for how to make those better. The other changes are more on the editorial side, especially on the transports. The security guidance mainly profited from removing support for more cornerish cases. So when there is transport layer security around, certain optimizations are just now not described as possible, which vastly simplifies the security handling. So what's left for going forward? Because I think that the parts where we need to process the input that has come from the larger IETF with all this SVCB stuff is now in a rather good shape. So we can look at what is left outside of that. There's one long-standing item about how we describe which URIs this is applicable to. The current text focuses on a mechanism where the link relations are relied on, and one resource, the root resource, hosts some other resource, that other resource has links going forward that are also hosts like, and that builds a graph out of kind of which resources are around to which things apply. That is very clean from a theoretical point of view, but looking at how things work in HTTP with more focus on the origin, that may just be the simpler way, both in terms of implementing it, in terms of tracking it, and also in terms of wording it. So I think it would be a good idea to make the switch, but there are pros and cons for both, so I'd like to hear your opinions there. If anyone has any right away, I can also pause here. Seeing nobody run to the queue, I'll continue. Relatedly, there is the question of how are descriptions in our C6690 format both best handled when a device says, hey, I do have some long-term stable name, even though you're contacting me over a short-lived, for example, linked local address. I want to advertise both. How do I phrase that best in 6690? I have no strong preference which direction we go, but as this document is approaching completion, we should make a choice. We could also say that we don't think that 6690 style discovery is not too relevant, but then again, the possible successor, Coral, is a bit stuck because I didn't get to make much progress in that over the last year. So we should probably have a story for how 6690 documents should look like here. And then the last.
Yeah, it would be a bit. The question you posed on the previous slide: do we care for or care about? Yeah, I think we need to make this work. But yes, we maybe want to make it work even better when we have new ways of doing this. So I think we do care. It's just that maybe we are optimizing for something else.
Good. The good thing is that this question will really not be relevant for something else. So if we decide to say that, hey, for 6690 we prefer the lower version, that is just more compact, but would need some elaborate reasoning to recanonicalize what this actually means, those mental hoops we have to jump through will just go away when not using 690, and they're not technical hoops to jump through. So an implementation can just dereference /foo and work with that. Yeah. So do you have a preference on which of those versions to focus on?
I probably would have to look at a few examples of this.
Okay. So the last part, the last of the open question is what precisely to do with the appendices. So there are, I'll just jump back briefly because it's probably more illustrative there. There are two appendices. One is about how to use SVCB records or service parameters for co-op. And this becomes relevant when a resolution provides yields different results, and not all of those results are immediately usable. Then the parameters in a service B record would clarify that. Right now, this is phrased as alternative history in the sense that if co-op had this from the outside, we would have done it that way. It wasn't there, so it wasn't done, and now we have co-op plus TCP, so we don't need it immediately. Do we need to phrase that here, and if so, with which motivation? Because we have co-op plus TCP, we can express things. And the other question is that if someone wants to express literals, where do those service parameters, which, by the way, I'm not really defining here, but importing from the DNR draft, which can, with the split we agreed on a few minutes ago, be simplified. Where do those go when we have a URI literal? And that appendix is a bit of a mess because it's introducing something out of necessity. I think the way it does it is kind of usable, but it's just it's really just a Strawman draft. So maybe with some reviews from the working group, this could become better. Yep, those are the open questions. Where do we go from there? I think it would be helpful to have reviews. Thank you.
Yeah, you ask a good question in the last line of this slide. So what will be our opportunities to actually get some interop on this?
Well, I'm working on implementation on implementing this with AIO co-op, but it really needs in AIO co-op there's a bit of API work, or there are differences in APIs for how to use it, because right now AIO co-op interferes very little with the process of URI resolution. It doesn't do its own caching, so an application, much of this I can do interrupt testing, but it is with a particular application that includes this. It would be preferable to test this with something where those processes are automated in the co-op library, but that is currently not planned for AIO co-op. So interrupt testing would mainly be about particular applications using this. And I don't have an immediately obvious example where to integrate that.
Yeah, I'm also wondering what venue we would use for this. I mean, we can always do it over the internet, sure, but is there an event we could attach this to? Do we do it at the next hackathon, or what's the right way to do this?
I don't know yet. I think that will largely depend on the participants. So, for example, if I manage to include some of that in Riot, it would also be a possibility. We'll have a Riot summit later this year in Vienna. Possibly do some preliminary stuff there with people from that community, and then continue at IETF venues. That will be in September. So,
thank you.
Thank you, Christian. Speaking as an individual, I think that the historical or a possible history information that appendix is useful to have around somehow, just to give more context to the reader. So I think that content doesn't hurt, at least as an appendix. It's good to have.
Thanks.
Okay, thank you so much. If there's no other questions, looks like none in the chat at least, we can move on with the next presentation, and that should be ESCO.
Hi, good morning.
Hi, ESCO.
Hi, thanks for sharing the slides. So
Yes, you
just
should
looking
have
at,
control.
yeah, I see it now. Very nice. Thanks. So I will present proxy operations for co-op group communication. So this is a relatively recently adopted as a working group document. And I'm presenting also on behalf of my co-author, which is Marco, you just heard. And yeah, what's the scope of this document? So what we want to do is basically define co-op proxy operations for co-op group communication. So to have a way of signaling between a client and a proxy using co-op options. And the idea is that through the proxy, client can basically reach a group of co-op servers and gets the responses, the individual responses from all these servers relayed back to itself. And this should also support the different types of proxies that can be defined using co-op. So we have forward proxies and reverse proxies. Also, we do consider a change of proxies as well as the HTTP to co-op proxies. So in this case, a proxy needs to be aware of course, of group communication, that it's ongoing, and yeah, also clients need to be configured to do it. So that means there is some yeah, authentication and authorization relation between the client and the proxy, so that not everyone can come in and send group communication requests to that proxy. So here's a picture that basically summarizes that protocol. So you can see the proxy sends out the group request on behalf of the client there. And what the client indicates is that it's basically interested in handling these multiple responses, and that it's also capable of handling these multiple responses. And we combine that also with a time indication now. So there's basically a multicast timeout option that basically includes that time that the client is willing to wait for responses. So the client can also indicate for how long the proxy should be collecting those responses and forwarding them. And the proxy now also includes information, because the client cannot really see where did a particular answer come from, and it might not be basically by not be in the response indicated, okay, who is basically the entity answering it. So we have this option included there, that the proxy knows where the response came from and can add that to the response. So we used to call that response forwarding, which is the name of the option, and now it's in this update of the draft, it's also renamed to shorter name, reply to. So it helps the client to distinguish those responses from the different servers. And it also helps the client to, if needed, contact those individual servers, or one of them or a few of them. And this might be directly or via the proxy. And that's done using addressing information that is included in that option, the reply to option. So for security, that's also considered. So we can have a group OSCORE used for end-to-end security between the client and servers. And also there can be security between the client and proxy on top of that. So this can use DTLS or TLS or OSCORE. So there the options are open. So this helps also the proxy to authenticate the client, for example, before doing the operation. So there's basically 2 layers of security here. Okay, I'll go to the next one. So the purpose of the presentation here is just to do a quick walk through the changes that have been made in the latest revision. So I will start with that. So there's always a couple of simple changes, of course. So we have the editorial fixes, readability improvements, and I can say we found some typos even. So that's all, fixed. And there are some clarifications made. So we have now a definition of the term individual request in the terminology. So we use that term a lot in this draft. So the individual request is basically the request of the client going through one of the servers within the group, which could be a direct request if the proxy has that direct addressing information, or it could be indirectly via the proxy. Sorry, I meant if the client has that addressing information. So it depends on what addressing information the client has. It can either do a direct request to the origin server if it wants to do that, or do it through the proxy again. In this case, the proxy will be acting not as a basically a group proxy, but group communication proxy, but as a regular one-to-one communication proxy. Also, we clarify that UDP over IP multicast is the default assumption for the transport. Of course, there can be alternatives, but we consider those to be out of scope for the moment for this document. And third bullet here is the change that we also consider the new co-op options proxy CRI and proxy scheme number. So defined in href draft. So these can be used as an alternative encoding for basically the information sent to the proxy by the client. So this proxy should support both formats, basically the older one and the new one. So I'll continue with updates. There's also 2 points that were discussed in previous interim meetings about reverse proxies. So thanks to Christian for raising these points here. So the first point was the discussion about whether the request from the client always has to include the multicast timeout options or not. So you could say if the client does not include it, there is a default timeout used by the proxy. And this seems to make sense for cases like reverse proxy, where the proxy is actually can be kind of hiding the fact that it is a proxy. So that means the client does not include any special options. But this was discussed, and we all think in the end of the discussion that it's better to have basically the proxy require this option in there. So that also provides an indication that the client is willing to get multiple responses and is also able to get multiple responses. So that provides some extra safety in the protocol. And the point number 2 is that we did some edits to not use the RFC 8075 style of encoding of basically a URI for the proxy within URI path options, but we use more the co-op way to do it, which is cleaner. Okay, I'll move to the next slide now. Just speeding up a little bit in view of time. So this talks about the reply to option, which was the former response forwarding option. So we clarified the meaning of this option. So it's basically the information contained in it is not necessarily the address of the server always, but it's basically addressing information that you need when you want to contact that origin server, which could be through the proxy or it could be directly. And of course, we're looking still for suggestions if there are any better names. We did consider some. You can read them on the slide here. But reply to is at least, nice, short, and catchy. Although we don't imply that there is a requirement to reply. So it's an optional reply that the basically client can make. So there's also new encoding of the option value. It's now using CRIs, which we did not have before. So I will not go over the details here, but it should be nice and aligned with the CRI format. There's also for the HTTP header field. That's basically the last bullet here. There's also an update of the encoding of that. So the idea we had was to use the same as a co-op option, so reuse that, but then include it in a HTTP compatible way using base64 URL encoding. Okay, and let's see how much there is to update. I think might need to skip a little bit of this if you have time. This goes over some details, so how the reply to option is used in different setups, because we cover all these different cases: forward proxy, reverse proxy, and also reverse proxy, where basically the also the individual servers are hidden. So basically the proxy does not allow access directly to the individual servers. So instead it provides addressing information of itself in the reply to option. So that's also cases we cover. So for these different cases, you can use the option in different ways. So with the two parts, so there's a CRI part and the CRI reference part. So then up to the next step. So this is the final slide we have here. We have plenty of work to do still for the next steps. So what we want to do is maybe consider if it's possible to cancel ongoing response forwarding. So it's basically a timeout. Is it possible to terminate that early, maybe? And quite some other things here, adding examples, for example, and many more things. So any comments on this are, of course, welcome. So let's see, are there any questions on the draft or the next steps?
Yes, thanks. There were just a couple of suggestions in the chat, of course, on the option name, to consider reply from instead. It's just as nice, I think. And it's good also to avoid confusion with yet another option that is around. And Karsten was also suggesting using SF for the HTTP case. So I don't know the details, but it should be quite aligned with what we have considered already, just more powerful.
Okay.
So we can have a look into that.
Yeah.
Okay. Any more questions or comments for Esko? Okay. If not, thank you again then.
Yeah, thanks.
We are 2 minutes ahead of schedule. And the next presenter is Richard with also capable proxies. And now you have control.
Right. So yes, hello everyone. So my name is Richard Höglund and I'm presenting some updates on this draft of OSCORE capable proxies. So basically, the scope of this document is updating the OSCORE RFC to define the usage of OSCORE in communication legs, including proxy servers. And this means it can be between the origin client server and the proxy, or also between two proxies if you have a longer chain of proxies. Practically, this means that an OSCORE endpoint can now be not just an origin server or client, but also an intermediary device. And it includes in this draft rules of how you should escalate protection of the co-op options, meaning that certain options that are originally defined as class U or I should be encrypted when possible. So basically, we have a set of rules that provide you information that indicates that when should you protect an option, even if it's class U or I, to maximize the amount of options that are actually protected. And this becomes possible because now you have this nesting and chaining of the OSCORE contexts. And that brings me to point 3, which is about explicitly admitting this nested OSCORE protection. So OSCORE and OSCORE. So typically this could be between, first you have a OSCORE between client and server, and then you have yet another layer of OSCORE between the client and proxy. Now, normally you would have maximum 2 OSCORE layers for the same message, one end-to-end, and then one between 2 adjacent hops. But you can apply more than 2 layers if you wish to. And the focus is OSCORE, but the same applies to group OSCORE also. So, what have we done since IETF 1.18? We received some feedback from Christian and Göran, so thanks for that. Version 1 was submitted before the cutoff. And then just to give an overview of some of the updates we did, we updated and added some references, a number of editorial fixes, fixed some notation in the examples of Appendix A, mentioned this onion co-op, which is another draft from T2TRD as one potential use case. We also consider the proxy CI and proxy scheme number options. And then we have 2 points I will go into more detail, which is about revising the escalation of the co-op option protection and also revising the processing of incoming requests. So the escalation of the protection of co-op options, we now list that explicitly as an update point for the OSCORE RFC. And in section 3.1, we revise these escalation rules. And basically, it defines that you have an outgoing message that you want to protect with OSCORE, including an option. And this option was originally class U or I. Of course, if it's class E, well, you should protect it. But if class U or I, then these rules help you determine if this option should be actually treated as class E and thus protected. Rationale is to encrypt and interact to protect whenever possible. And we basically have 3 cases, meaning that any co-op option where all these following conditions hold. And if one of these conditions match, you will treat this option as a class E option. We also have a state diagram in Appendix B, which you can see in the next slide. And when we were working on revising these rules, one side effect we noticed is that when no proxies are involved, we end up actually protecting the URI host and URI port options. So they will also be protected if you have a server and client setup. And the good thing is, of course, this solution will be backwards compatible with endpoints that will not actually implement this update. So let me go to the next slide. And this is the flow chart of this encryption escalation. I won't go into it point by point, but overall, it's a set of rules that help you determine that, yes, I have this outgoing message M, including an option, and I'm going to protect this with OSCORE. And now the question becomes, okay, do you actually protect this option or not? And then by following these rules, you will end up with a determination that, yes, even though this option was originally class U or I, it should be protected, or no, it should not be protected. And of course, again, the point is to encrypt as much as possible, but some options you cannot encrypt because, of course, they will actually be needed to be read by an intermediary that for instance, if you have a proxy that is in the chain that's not using OSCORE, of course, you cannot protect options with OSCORE, then the proxy will not be able to decrypt and understand those. So going to the next slide, we also did some updates on the processing of incoming requests. One of these points is that was pointed out by Christian actually, is that before you decrypt a message using OSCORE, you should check if you're authorized to perform this operation. And practically this means checking if a security context is available and in an allow list of that the alleged sender is in an allow list that informs you that you're fine to actually decrypt this request. And this has some use cases, or this is applicable to preserve the anonymity of a server. If you have a reverse proxy in front of it, there is an actual scenario where this can be important to do. Göran pointed out that the word authorization is actually a case of something more general. So we switched the naming to say, instead of authorized operation, we say acceptable operation. And acceptability depends on local configuration and authorization. For reverse proxies, yeah, we consider that a reverse proxy can actually act upon the URI port and URI host options. So they are also, in a sense, considered now to be proxy-related options, which is relevant for our the rules we defined. To continue on this, another case that was noted by Christian is that if a request comes to a forward proxy and the target is the proxy itself, the proxy should actually directly consume this request based on the that section in the co-op RFC, and this is for more efficient processing. And previously we were saying to send that out on the network, but now in the rules it's stated correctly that you should immediately consume that request. Another point, to avoid infinite looping in our rules, because in the rules that we have, as you can have nested layers of OSCORE, you may actually end up going back to the start. So you do multiple nested decryptions or encryptions. So to avoid possibility of infinite loop, we now say that an endpoint should define a maximum number of OSCORE layers that it is able to apply or remove. And this can have certain bounds, like you cannot have more layers than you have active OSCORE security contexts. And if this limit is reached, the decryption will fail on the reception side. We also updated the state diagram in Appendix C. And it was a bit tight, but we managed to squeeze in some of these additions that were pointed out to us. So next steps, well, we want to look a bit closer at processing the hop limit option, because that is to be used in a very particular way. And we want, of course, to make sure that some options that exist, that the rules we define do not interfere or break their functionality while still maintaining the maximum level of encrypting whenever it's possible. We also want to look at when should you and define that more clearly, that in certain cases you should actually add an outer option after you produce the corresponding in the encrypted option, and this is relevant for observe, for instance. We want to handle multiple responses for same request, and this is based on the same rationale as the core OSCORE GroupCom document. Extend the security considerations. We want more example of message exchanges, including also reverse proxies and a chain of proxies. And then we had this proposal and suggestion that this concept of OSCORE and OSCORE, nested OSCORE protection, can get its own name, for instance, MatriOSCORE. And any comments and reviews of this document is very welcome. Thank you.
So can you say anything about the implementation status of this?
We plan to implement it, but we do not have an implementation, and it will be some time before we have one. But we have in the past, I was involved in implementing OSCORE for Java and adding it to this Californium co-op library. so that we have a good basis and starting point, and the intent is to extend that code to enable this.
Thank you.
Thanks, Richard. Any comments or questions? None. We can switch for the next set, and it's you again.
Yes.
And you have control.
Yep, thank you. So yeah, moving to the next document. This will be an update on the key update for OS Core, and that we call Kudos. And also another related document that was split out from this one. So just to recap what this is about, Kudos is a means of doing key update for OS Core, and that's now the only, let's say, remaining part of this document, since actually we split out two other parts of this document. But basically, Kudos, the idea is that you want to renew your master secret and master salt, and thus derive new sender and recipient keys. There's no change to ID context parameter, and you can achieve perfect forward secrecy. It's inspired by Appendix B2, and it's actually agnostic to however you initially established your OS Core context, whether it was pre-configured or with ad hoc. Regardless, you can use Kudos for doing a lightweight key update. So that's now point one. That's the core part. That's really the document now. Previously, we had this point two, which is about EAD key usage limits. That was split out into its own draft March 2023, and now lives there in its own draft. And then recently, we have point three, which is that we had a procedure for updating the OS Core sender and recipient IDs within this Kudos draft. But we discussed and agreed during IETF 118 to split that out as a separate draft, which has now been done. And that's now also living in its own draft, the Core OS Core ID update. And I will come back to that briefly later. So the actual Kudos rekeying procedure, it's based on an exchange of nonces between a client and server. And you place these nonces in new fields that we define for the OS Core co-op option. And then we take these nonces and we feed them into an update CTX function we defined together with the old material from your old security context. And that basically produces on the client and server side a new security context to use with a new master secret. And that's meaning that you will have actual new sender and recipient keys to use. And you can see here an illustration of the co-op option and how it was extended to have a place for having the nonce and also having a place for the old nonce. And this is something particular that's only actually needed in the reverse message flow. On the right-hand side, you can see the overall message flow and the request response. You have exchanging the nonce there. Nonce N1 and nonce N2 is exchanged between the client and server. And then you also derive this CTX new based on the nonces and previous context material. Yeah, so an overview of some updates since the IETF 118. Christian gave multiple points of feedback. Thanks for that. We submitted version 7. And to summarize the updates, I have a list here, but I will go into these one by one, so I can just continue instead. Yeah, so point number one was that we wanted to, that was pointed out that in some situations it may actually be fine to allow usage of non-random nonces. Previously, we always refer to the nonces as random values in the text, but in some scenarios it can actually make sense to use counters. And we define this concept of a capable device, meaning that it can actually persist context information after a reboot, meaning it can write to persistent memory. So that's a more capable device. And such capable devices can actually use nonces as counters because it can store and remember the nonces for after it has rebooted. So now we explicitly allow the usage of nonces as counters. And we do recommend that the counters have the same size as the nonces, which is recommending 8 bytes. And to put the solution shortly, the non-capable devices that cannot store to persistent memory, they must use random values. However, the capable devices may use a value obtained from a counter, as long as you can ensure the counter values are not reused. And these can, for instance, take inspiration from how OS core prevents reusage of the sender sequence number after reboot, defined in Appendix B11 of the OS core RFC. And there's some privacy considerations that it is preferable to use random nonces for privacy, because if you use counters, it can leak information about the frequency of rekeying done. So of course, this is a consideration that has to be taken into account if it's a trade-off between using counters and using the random nonces. Another thing that we changed was that previously we really considered a kudos execution to be strictly a request-response pair. However, it was pointed out that it may be fine to have more flexible message flows. So for instance, Christian had a scenario based on the simple registration to the resource directory, where you may actually want to have a request be kudos message 1 and then another request be kudos message 2. And there's really nothing stopping this from working. We also elaborated on this now and provided some examples. So basically, you can see here in the example to the right that the client sending the client server on the left is sending a request to the pair on the right, and then the pair on the right is, for whatever reason, it may at that point wish to send a request to the pair on the left, and there's nothing that is preventing kudos from being done in this kind of pattern with 2 requests. And this again was very relevant for the resource directory simple registration procedure. Other alternatives are also possible. You could have the second kudos message be a response. That's actually a response, but it's a response to a different request than the first kudos message. For instance, maybe there's a notification that is just going out from the server, and that can serve as kudos message 2. So overall, it's about not having this strict coupling between yes, kudos must be a request and response pair. It can actually be more flexible than that. Continuing on, we also added now that capability that a kudos message can actually be as a normal, regular application message. Because in the past, we always said that a kudos message must target this special, well-known kudos resource, but there's actually nothing preventing the kudos message from being just a normal application request that the client wishes to send at that time. So when the client wants to do a request to /temp on the server, this request can then also serve as kudos message 1. And practically, this means that the kudos message can target any resource at the server. There is some subtleties that you need to consider here, which is that the server cannot be sure that this request is fresh, because it's really sent using a just generated new security context. So if the service needs freshness, you can actually respond to this initial request with a protected 401 serving as kudos message 2. And that 401 can then signal to the client that, okay, the server needs freshness and it responded with the 401. So the client now has the choice to just resend that initial request that it originally sent to actually retrieve the resource representation. Of course, the well-known kudos resource can still be used. Maybe the client is not wanting to send a request at this moment in time. If you are targeting the well-known kudos resource, there shouldn't be any payload in the co-op request prior to OSCORE protection, because that doesn't make sense. There's no really content at the well-known kudos resource. Yeah, so another point we covered was the splitting out of this update of OSCORE sender recipient ID procedure. And just to recap what this was about, It's a method for two pairs to also update their OSCOR sender and recipient IDs. And this was based on some earlier discussion on the mailing list. So basically, it can be a standalone procedure, and that's how it's defined in the separate draft. And we also showed there an example of how it can be embedded within a kudos execution if you wish to run kudos combined with this ID update to actually get both new IDs and run kudos at the same time. And yeah, it has a number of properties. Basically, we have a new option defined, this recipient ID option, class E, where the sender can define what new recipient ID it wishes to use. So both pairs basically choose their own new recipient IDs. Of course, both pairs have to agree and opt in to actually do this update procedure, otherwise the communication will break. And changing the IDs actually, by the way, triggers a derivation of new OSCOR security contexts because the IDs are part of the key derivation procedure. You shouldn't do this immediately following a reboot. If you're running it standalone, in such case, you should first start by running kudos. And there's some rules on not reusing the IDs. For instance, you shouldn't reuse an ID that has not, it should be unique within this master secret, master float, and ID context. And we also now have examples in this draft in section 211 and 212. And one point of wanting to do this ID update can of course be privacy, that you're moving to a new network and you don't want to, you want to prevent some kind of message linking between your previous IDs and these new IDs that you're using. So it can be have privacy benefits to do this ID update procedure. Yeah, so summary and next steps, basically, yeah, to cover briefly actually the limits document that I mentioned. This is about, it's basically taking inspiration from the CFRG AAD limits document, and it's defining how many times it's safe to use an OSCOR sender key or recipient key before you start compromising the security properties of the AAD algorithm. And this is something being defined in CFRG in a more general setting. So basically, we did submit version 2 of the limits document in January, but we're not updating it so extensively because we're really waiting for updates to the CFRG AAD limits document to see what the next steps there is, and also feedback from other possible sources. Otherwise, yeah, basically our plans for the future, we want to, yeah, see Göran in the queue.
Yeah, I just want to point out, sorry, can you hear me now? Is it loud enough or too loud?
It's not
fine.
good here.
Good, thank you. I just want to point out there was a new paper this year on symmetric ratchets and keychains, which is explicitly mentioning kudos. Well, it's mentioning a lot of protocols, TLS, DTLS, quick signal, MLS, ad hoc, OSCOR, and so on. And there were some recommendations about key updates. Have you looked at that paper?
I'm aware of it. Yes, we are aware of it. And this is one piece of feedback that we do want to take into account. I haven't read it through myself, but I'm very much aware of it. So
yeah,
that is.
No, but I mean, the review looks. Oh, great. The review looks good, so it's no worries. But there are some recommendations there, so please have a look.
Yes.
Thank you.
Thank you. Yeah. So overall, next steps, we have all the open issues as actual issues on the GitHub repository of the draft. We plan to continue processing those. And otherwise, we're actually working on an implementation of this both in Java and C that we, of course, will interop. And we're also planning to do some evaluation of these implementations. Yeah, and of course, as always, any comments and reviews are very welcome. Otherwise, thank you all for listening.
Thanks a lot, Richard. And I just added to the chat the links to the paper or papers that Göran mentioned. I could track two of them, both from John Mattsson. So please have a look at those.
Yes.
Any more comments or questions for Richard, anyone? Right. Yeah, Göran referred to the second paper of those. Okay, thank you so much again.
Thank you.
And then we move on to the next presenter, who is Christian, with 2 presentations in a row. First, the non-traditional responses, and you have control.
Yep, thank you. So hello again. I'll make it brief here. This is an update on what's been happening in core responses, which Carsten started and I've joined in with. The core responses defines non-traditional responses, which are responses that are not just the one single response that was generated by a request that was sent on the same transport. There are multiple ways in which those can happen, and many documents, maybe I'll just hop briefly to that backup slide here. Many documents explicitly or implicitly define such non-traditional responses. And to make the work of all those document authors easier, or at least the work of the implementation authors who might this document is not trying to redefine existing options in terms of non-traditional options, but it may be helpful for implementers to think of some existing things in terms of non-traditional options to simplify their implementations. So what the document does is it does 2 things. It defines some new utility responses options that can be used to create non-traditional responses. And what I'd like to focus on today is it also describes how non-traditional responses can be defined, and gives basically copy-pastable or referenceable, ideally, text for how those would behave. There's one very concrete addition in the latest version of the document, that is, it describes how non-traditional responses are to be handled in OSCORE. So far, different documents had to write this manually or repeat something that has been written in OSCORE for the purpose of observation notifications, which are kind of the archetype of non-traditional responses. And there's now a concrete list of steps to follow when working with non-traditional responses. So no matter whether the request was actually sent or not, and those are called phantom requests and used in some kind of notifications, there needs to be a sequence number and sender for the request, because those will be referenced in the responses. No matter no matter when a response is generated, there is only one response that may ever reuse the request nodes. And responses can be ordered. Responses may need to be subject to the replay window, subject to some, basically to the expectations, to the application's behavior. And if there are follow-up requests, as there are, for example, with observation updates, then the client needs to tolerate that there might be reordering between the received responses, and either decrypts the responses with the old context, or tolerates that there are decryption failures because there was just a notification on the fly in flight while the client sent the updated request. And I think that's a rather concise set of rules. I'd like to ask everyone who has implementation experience or specification experience with OSCORE to review those, because ideally future documents such as proxy OSCORE should just refer to those, and multicast proxies should just refer to those, and not reinvent things here. Yep, I think that's it from my side for this document. There are no plans for having interrupts on that yet, but I think we should try to do that. Of course, interrupting on that may not take the form of working on that concrete document, but working on a downstream document. So I think that would be the best place to do that. And the other question is, like, where do we go with this? I think it's it is something that should be valuable for the working group. So do you want to have it as a document? Thank you.
Yeah, this is Marco. On the topic of interoping and so on, other than the obvious co-op observe and so on that were well covered in the past, of course, probably the next best target is really GroupCon proxy, for which we have, for a previous version of the document at least, some basic running code, even with GroupOScore already. So barring some possible update, that's possibly the next best useful target. But specifically on the use of OSCORE or GroupOSCORE in that setup, that document at least doesn't add anything special, really. So at least about that particular corner doesn't help in the sense that it doesn't introduce anything new or strange.
No, yeah, it's so I reference the wrong document. It's not about group proxying. It's about no, it's not about OSCORE groups. It's about a proxy sending multiple responses that were received as part of a multicast request. So that would be multicast proxies and not group multicast proxies, and not about the use of group OSCORE.
Okay. On your last question here, speaking as an individual, I said that before the previous meeting, I still believe that it's good to have this kind of document and resource to set a common ground and not reinvent the wheel. Find that other documents somehow came up their own way with similar concepts, but it's good to make things homogeneous in one single place that we can look at. So I think it's a good idea to have. I plan to give a review. Anyway,
Thank you.
Soon enough. Thank you. Your answer is +1. Okay, any more comments or questions on non-traditional responses? Heard and seen none. Next is Christian again. Let me just change that.
Jinx.
Off we go.
Yep. Right away, next topic. Core resource directory extensions. As you can see by the version number, this has been around for some time, and it's really a bit of a mixed bag. This contains some extensions that we could possibly have already done in original resource directory, but we really wanted to get that finished and not add more things. So, for example, it describes how you could use indefinite lifetime when there is some connection, for example, a registration over CORP over TCP, where the loss of the connection would indicate that the registration is over. So some on the more practical side, some really experimental things, such as looking into whether an interface similar to what the pub/sub broker has, with a different topic resource and a data resource, could be usable for resource directory. And for the latest version, that 10, there's a concrete addition about using the resource directory with ACE and ad hoc, and that's what I'd like to focus on today. The common assumption in both, or the common assumption in both those parts is that we have a very minimal co-op server that's acting as an endpoint, and that really does not want to implement anything that is hard to implement or that requires timers and any of the complex parts from an embedded device's point of view, when the embedded device is really like a 30 kilobyte flash-ish range. Such a device would only act as a server most of the time, but in order to do a resource directory registration, even a simple registration, it needs to send out one request. Both for ad hoc and ACE registration, it should be possible to send that request unencrypted, because that request would really not contain any information other than, hey, there's some device contacting the resource directory. There's just a 50-50 chance what it is doing, a lookup or a registration. So we're not leaking a lot of information there. And the good thing, once that simple registration is started, is that the resource directory can take the initiative and drive ad hoc. I think that should work quite well. There's one caveat, that is that if there are registration parameters different from the defaults, those would be sent in the plane. But at least for the most simple tests that I've made, there are no registration parameters sent. So this might be a usable way of operation already. Things are a bit more complicated when it comes to using ACE, because while co-op is very flexible in terms of role reversal, and you can just send a request the other way around, and OSCORE is very flexible. And ad hoc, while not kind of being completely symmetrical, can be used in both directions using the reverse flow. ACE is rather strict in terms of what it defines as the resource server and the client. So when ACE role reversal comes into play, there are gaps in ACE that were found as part of specifying is maybe an exaggeration, describing those ways of using a resource directory. The slides link to two issues in documents that are related to ACE. One is the workflow and parameters. That might, as a result of this, gain the capability of describing both directions of an ACE exchange, and the other is in the ad hoc OSCORE profile, that allows the ACE ad hoc workflow to run even when ad hoc is used usually in the inverse flow, so that the token is sent in message 2. Those are work in progress in ACE, and I think that from as far as this document is concerned, next steps are mainly to process all of this into ACE, then revisit and come back and reevaluate whether ACE and ad hoc are now suitable to use the resource directory even with a very constrained endpoints. And I think any questions of whether things should happen in the working group are best deferred to when we have concrete feedback from ACE, or when there are people who want to pick into particular points that are already in the document from the other parts. And that's everything that I'd like to bring to the working group today about this document. Thank you.
Thank you, Christian. Any comments or questions?
I have a question. It's a practical one. Like, how do we do with experimental drafts? Like, in process-wise, they become RFCs and they're updated, or are they treated in any way different? Sorry for asking. You should know this.
Yeah, so we have different labels we can use here: informational, experimental, standard strict, BCP. And each time we have to decide which one we want, but the processing of these is the same. They receive different levels of attention by the ISG later on, but in the working group, I think we just need to make up our mind which label we actually want.
Thank you, Christian. And from my point of view, since I also took part in the early thoughts related to ACE and ad hoc, the direction looks promising, actually. So hopefully I can help out also in the text in this particular document. But thanks for starting this. Okay, if there are no other comments or questions, we move to the last but not least presenter, Carles. But before starting, does anyone have in mind any other business to discuss in the very end? Just to tune with the remaining time. So hearing none, in principle, Carlos, the rest of the time is for you, so don't stress to fit into the 5 minutes. Oops.
So can you give me the presentation so I can give Carlos the presenter?
Oh, I still have that one, that's right. To you then. Yes.
Yep, now it should work.
Yeah, I have control now. Okay, hello everyone. So my name is Carlos Gomez. I'm going to present. I was prepared for around 5 minutes for 2 documents, which are both in the area of CoAP for space communications. The first one is entitled CoAP in Space. My co-author here is Sergio Aguilar from Sateliot. So this is the introduction. Deep space communication occurs between devices on or orbiting different celestial bodies, such as different planets on the solar system. However, these environments entail very long delays, intermittent communication opportunities, low energy availability, low bit rates, among others. More than 2 decades ago, the IP protocol stack was considered unsuitable for deep space. This led to the creation of the DTN architecture and its fundamental component, the bundle protocol. However, a very recent draft revisits that conclusion and claims that it is feasible to run an IP protocol stack end-to-end for deep space. And that document suggests the use of CoAP along with also HTTP. And in this document, we claim that indeed CoAP is a suitable protocol for deep space, because mostly CoAP has been designed for constrained node network environments, which share to some extent quite similar, some similarities with the characteristics in deep space. So this document has an intended status of informational, and we aim to offer guidance of how CoAP can be used for deep space. So this is a very quick overview of the content in this draft. First of all, regarding the underlying transport, we propose using CoAP over UDP, because in this case, reliability is still optional. There's the shorter header size of UDP. Also, there's better support for group communication, and there is not the penalty of, for instance, the initial handshakes, which occur in reliable transports. Then there's a number of CoAP parameters which may need to be modified or will have to be modified. Also some related times. For instance, mstart is by default 1. However, it is possible to increase this setting, and that's as long as there's some mechanism, some way to ensure that there is no congestion issues there. However, an open question is what would be the right setting for mstart in some deep space scenarios. Then another parameter is ACK timeout, which is by default equal to 2 seconds. However, for instance, the round trip time from Earth to Mars can be up to 45 minutes, considering only propagation delay. So yeah, ACK timeout will need to be updated as well, suitable tune for each particular scenario. Then max retransmit is by default equal to 4. However, perhaps we might want to consider lower values for this parameter in order to avoid maybe too high latency for CON messages. Then there's the times shown here, max latency, exchange lifetime, non-lifetime, which are all in the order of 100 seconds or a few hundred seconds. So these will have to be increased by at least a couple of orders of magnitude in deep space environments. And then there's an open question, which is regarding congestion control. Do we actually need congestion control in deep space environments at all? By the way, I take the opportunity to also announce that tomorrow there's a side meeting called Deep Space at 8 a.m. local time here. And both this document and also this open question will be discussed in further details. So feel free to attend it if you are interested. And then also Co-op offers, of course, the observe option, which is very useful, suitable in deep space environments, as it allows a client to obtain resource representation whenever a resource changes in a very efficient way. Then regarding blockwise transfers, when needed, we propose using RFC 9177 because it is not constrained to stop and wait, and it supports efficient loss recovery. I know, well, Christian already made some comments there. And yeah, also regarding security, OSCORE is interesting, among others, because it can avoid initial handshakes if there is the use of some pre-shared materials. So this is the second document. It's entitled Co-op over Bundle Protocol. Here, my co-author is Ana Calveras, also from UPC. So there has been some interest from the DTN working group in exploring Co-op over BP. So this document aims to specify how Co-op can be carried over BP. Here, the intended status would be standards track, and there would be two working groups which may have to be involved in the process, the core working group and the DTN working group. If there is interest, perhaps at some point we'll need to maybe see which is the home working group, but in any case, we plan to keep both working groups in the loop. And this document includes, like, generally two parts, one which is quite similar to the content that I quickly presented in the first document, but then also some more specific content focusing specifically on how Co-op is supported over BP. So regarding the latter, here's a quick overview. First, we provide the architecture for Co-op over BP, the protocol stack, then also which would be the abstract layering. Then also the messaging model, which we understand should be the same as in Co-op over UDP, since BP and UDP are both message-oriented protocols which do not support retransmission. Then we are considering whether it might be a good idea to increase the message ID size from 16 bits to 24 bits. In this case, that's in order to avoid a significant limitation on the maximum message rate for a sender. There are more details about that in Appendix B. Then Co-op supports blockwise transfers, but BP supports its own fragmentation and reassembly mechanism. So in this regard, we are offering the option for sender to use blockwise transfers if the details about contacts in the path from the source to the destination are known in advance, but that's as an option. Also, we understand that we need, and actually we attempt to define a new Co-op over BP URI scheme, here called Co-op plus BP. And then in Appendix A, we provide a number of tables which aim to provide reference values regarding some times or related parameters for the case of interplanetary communication. So one example is this table here, which provides round-trip time between two celestial bodies of the solar system. And also this would correspond to the minimum timeout that would have to be used, or some equivalent exchange lifetime for max retransmit equal to 0. And by the way, this is in some idealized scenario where the latency comprises only propagation delay. By the way, this document will also be presented in more details on Friday in the DTN working group session, Friday session 1. We have 25 minutes in the agenda, so if you are interested, please feel free to attend. So yeah, this is my last slide. Not sure if there are maybe comments, questions.
Karsten?
Yeah, thank you. As individual, when you say Co-op plus BP, this is a bit different because we don't have an IP address there. We have the things that the bundle people use to identify the systems, endpoint identifiers, or whatever they are called. So maybe the same consideration applies that if the structure of the information that is in the host position in the UI already implies that we are using the bundle protocol, we don't really need to have it in the scheme. I'm just wondering about that. I'm not saying it is so, but it may not be necessary to do that.
Yeah, okay. As long as I understand, well, I'm not sure if the identifiers which I used in BP are like unique, like cannot be confused with something else, let's say. But perhaps that could be. So yeah, that's definitely a good point. We need to check if that's the case, and then maybe remove the plus BP if it works like that.
Yeah, you also have to find a way to actually jam the endpoint ID information into that place. So you already have to think about a way of encoding things, and percent encoding in that space doesn't work too well. So
okay. Yeah, because I received already a comment about using the percent encoding and so on. Yeah.
I think I'm next in the queue. On the draft about the co-op over space, that's very interesting, very new work. The topic of the space has popped up in the IETF a few times already in the routing working group, for example. I don't know if you are familiar with the Tony Lee's draft that was presented yesterday on routing protocols for space LEO constellations.
Well, yeah, not really. I haven't read the draft. I know about this effort, but I should.
Mainly because it was adopted as working group item. Also, so one problem that draft in particular has is that it has been worked a bit in a vacuum from like IETF vacuum, basically not a formal feedback from satellite vendors or manufacturers. I'm wondering for this draft in particular, I see one of the co-author, your co-author is working for a satellite company.
Yes.
Could you maybe but you have actual deployment expectation? Is there anything that you could give some insights about there?
So not at this moment, meaning not yet, but it would be perhaps in our roadmap to try to actually have some sort of deployment. So I guess maybe we can have experiments like not in space, but perhaps in the long term. I think that would be a great idea. And yeah, so at this moment there is no such experiments yet, but let's hope that maybe in the future we can provide any insights if it's actually possible to really deploy co-op in space. Maybe there is satellite, but also deeper space, well, even.
Because all of this technology is like the new NTN type of communication. Yes. So there's a lot going on that as well.
Yeah, so precisely with my co-author, there is NTN is in scope. So maybe I don't know if we might even expand the document to include not only deep space, but also closer space, basically NTN scenarios. Thank you.
Okay, I guess I'm the next one in the queue. Yeah, just wanted to mention on the new proposed URI scheme for co-op that you had also in the previous slide. Yeah, I suggest to check section 6 of the document core transport indication for Christian. It is recommending, though not normatively, to start avoiding new URI schemes for co-op from now on, and instead rely on something like subdomain of .arpa, where you can still express as part of the authority what you mean, which here is, well, over bundle protocol with whatever other information.
Yeah, thanks for the comment. Yeah, actually I was not aware of that text, and yeah, definitely, well, I was checking the details during today's meeting, and yeah, we'll have a look, and perhaps, let's incorporate that guidance.
Awesome. Thanks for this work.
Thank you.
Christian?
Yeah, I think the URI parts we can hash out on the mailing list. One concrete question. When you mentioned the topic of NSTART, can you tell a bit more about the properties that we get from the IP network, given that the IP assessment described this as positive? Do we get things such as explicit congestion notifications in such an interplanetary network? Because that would ease the decision on what a suitable NSTART is and kind of how we can make the congestion control better if our round trip times are already in the order of magnitude minutes.
Well, I'm not sure there's explicitly congestion indications in BP. However, there is different flags in bundles that can be used to request reports, sort of status reports, sometimes from intermediate nodes, sometimes from the actual final endpoint. So maybe it's something that could be added in the future. However, yeah, BP also was a bit different in the past, meaning that recently there has been this version 7 standardized. In the past, it included a few more features, and now it is a bit more like, more similar to, say, UDP in a sense, meaning that it does not support currently retransmission and so on. So yeah, now it's a bit more like sort of sending datagrams out there, in this case, bundles. And I'm afraid that at the moment, there is not a clear way to provide congestion indications and so on. Then the point about NSTART is that, yeah, if it's set to 1, it may lead to stop and wait operation, which is kind of critical in deep space with the huge latencies. And yeah, it's an open question, which would be the right setting for some specific deep space scenario. And perhaps, well, this is something that has already appeared, more the general point about congestion control, do we need it in space? So there were like different opinions in the previous deep space side meeting in Prague. And tomorrow in the side meeting, there will be also a dedicated slot for that. So yeah, at this moment, I think there is not a clear answer, but it's definitely something really critical for performance.
Okay, thank you very much. We are now 2 minutes over time, but it was a very good use of this time. So I think we can close up the meeting. And thanks a lot, everyone, for your participation and contribution. Enjoy the rest of IETF 119, and see you at the interim meetings and on the mailing list. Thank you all.
Thank you.
Thank you. See you.
Bye-bye.